Okay, so continuing on the next page, we have 27 to the 2/3. The denominator becomes my index. Sorry, that's my son you can hear in the background. My index comes from my denominator, and I can raise 27 to the second power, or I can raise my whole radical to the second power. I chose to do it this way for this problem because I know the cubed root of 27. 27 breaks up to 9 times 3, and 9 breaks up to 3 and 3. Because my index is 3, I need 3 of the same factor in order to pull it out of the radical. I have 3 3's, so I can pull it outside of the radical. And because there's no factors remaining, there's nothing inside the radical. That means my exponent of 2 is still outside my parentheses, and 3 squared is 9. Number 38. I can distribute my exponent so that I have 1/4 times my exponent of 1, because my coefficient has an exponent of 1, and 3 times 1/4, which will be 3/4. Now, I could write this entire thing that's under the parentheses, in the parentheses, under the radical. Sometimes that helps when I'm taking factors out, and other times this way is easier. Let's think about this. 64 is not a perfect fourth. To find perfect fourths, we do 1 to the 4th, 2 to the 4th, 3 to the 4th, and so on. 64 is not a perfect fourth. So if I were trying to find it on its own, it wouldn't simplify, and I need it in radical form. This is exponential form. Radical form, when I simplify, I factor my 64 to 8 and 8, and each factor of 8 has 3 factors of 2. I need 4 factors to pull it out to the front. 1, 2, 3, 4. That means I can pull out a 2 to the front. But I still have 2 2's remaining. That will remain on the inside of my radical. 2 times 2 is 4. I have 3 factors of x. I need 4 in order to pull any x's out, so all 3 factors of x remain on the inside of my radical. This is a simplified answer. Looking at 39, the only difference is the numerator of my exponent. That means all of this could be raised to the power of 5 to get me my new answer. That also means I could have multiplied by 5/5 to each exponent before, but again, that's exponential form. Let's think through this. I could take all of my factors of 64, and I would have 5 of all of those factors afterward, which means I'd have one group of 2, another group of 2, and I would do that 5 times. How many 2's would I have left on the inside? I had 2 in my original one, so I would have 5 times as many 2's left from the original. That gives me 10 2's. But I need 4 to take each one out. It starts to get complicated. The point of this is to show you, if we take our 4th root first, then we find the answer of that and raise it to whatever power in our numerator, sometimes that is easier. So if I raise it to that power, that means I have 2 to the 5th, the 4th root of 4 to the 5th, and x to the 3rd to the 5th, which means I multiply my exponents. So all I did was multiply my 5 by each of my exponents, 1, 1, and 3. This is a lot easier than trying to figure out how many factors I have. But look, because of that, I have more factors inside that I can take out. I have 4 factors. I have 5 factors of 4. That means I can take 4 of those factors to the outside. Or I can make a group of 4. So here I have 5 factors of 4. I take a group of 4, which means I can bring one out. And I'm left with a 4 on the inside. How many times does 4 go into 15? Four goes into 15 3 times with a remainder of 3. Because 4 times 3 gives me 12, 13, 14, 15. That's a little crammed. Let's write it again. 2 to the 5th, I actually know, is 32. So I can take 32 times 4, which gives me 128. I have x to the 3rd and the 4th root of 4x cubed. Number 40. This goes back to product rule. I'm multiplying the same base with different exponents. Could be the same exponent. What I do is add my exponents. In order to add those exponents, I need common denominators. 1/3 is equal to how many 15ths? 5 15ths. 6/5 is equal to how many 15ths? 18 15ths. All I did was multiply to get a common denominator. I multiply my numerator and denominator of my first fraction by 5, my numerator and denominator of my second fraction by 3. So I'm doing 5 15ths plus 18 15ths, which gives me our problem says to write each answer in simplified radical form. That would mean my index is 15, and I have 3 to the 23rd power. Remember, if your index is lower than your exponent, you can take some out. 15 goes into 23 once, with a remainder of 8. So my simplified radical form would be 3 to the 15th root of 3 to the 8th. Wow. Number 41. The directions say, write each expression as a power with a rational exponent. That means I'm going the opposite direction. So my radicand goes in parentheses, and I raise it to whatever power I have. My denominator comes from my index. If there's no index written, your denominator is 2. Your numerator comes from your power. If you have no power, it is 1. This is a rational exponent, therefore I am finished. Number 42. My denominator comes from my index, which is 4. I have no exponent, so the exponent is automatically 1. So my answer is a to the 1/4. Number 43. My denominator comes from my index. My numerator comes from my exponent, b to the 2/3. Number 44. I rewrite my radicand inside parentheses. My denominator comes from my index. I don't have a power that the entire thing is raised to, so I will put 1 for now. This is not simplified. In order to simplify, we distribute our exponent. I get x to the 6/3, y to the 9/3, because I multiplied. That reduces to x squared y to the 3rd. That is simplified. Number 45. I rewrite my radicand inside parentheses. My denominator comes from my index. The entire thing is not raised to a single power, so I'll put 1 for now. You can't use the 2 as your power unless it comes from both. If my 81x was in parentheses and the 2 on the outside of that, I could use the 2 in the numerator. But it's not. So, I can take 81 to the 1/4 and x to the 2/4 by multiplying my exponent. Remember, your coefficient has an exponent of 1. I know that 81 factors to 9 and 9, 3, 3, 3, and 3. That means there's a perfect 4th of 81. We could have taken it at the beginning, or we can show that I need 1 of every 4 factors. That's why it's 1/4. Here are 4 factors of 3. So you need 1 of them for your answer. X to the 2/4 reduces to x to the 1/2. 3x to the 1/2 is my answer. Number 46. My radicand goes inside parentheses. My denominator is 5, my numerator is 1. I can distribute my exponent, and I get x to the 2/5, y to the 3/5. That is my answer. The next set of instructions says solve for the value of x. If you have the same index, you can multiply your radicands. If I multiply, I still have an index of 4. And I multiply 81 to the 3rd times 81 to the 6th. My bases are the same, so I can simplify that using the power rule, which is the first rule we talked about at the very beginning. That means I add my exponents, 81 to the 9th. I can now change this into exponential form because there's no radical in my answer. My index becomes my denominator, and my exponent becomes my numerator. What can I multiply by 2 in order to get me 9/4? You can set up an equation and solve for x, which means I will divide this fraction by 2. Dividing by 2 is the same as multiplying by 1/2, or taking half of something. So I should get 9/8 is equal to x. I can check my answer by multiplying this by 2. Twice as much of this will give me 18/8. If I divide my numerator and denominator, that reduces to 9/4. And that's what I started with. So my answer for x is 9/8. For number 48, my answer is in exponential form. So I'm going to change my radical form to exponential form, leaving my exponential form of my numerator. My denominator is 4, and my exponent is 3. Using the quotient rule, I can subtract my exponents. So I need 5/2 minus 3/4. I can't subtract these yet because my denominators are different. I need a common denominator. My common denominator is 4. If I multiply by 2/2, I get 10/4 for my first fraction, and I'm still subtracting 3/4. That reduces to 3⁷/4. So my value for x is equal to 7. For number 49, I can write 7 1/5 as my radicand using my index as my denominator and a numerator of 1, because I have 1 of this entire radicand. Then I multiply my exponents, and I get 1/15. So x is equal to 15. You can also realize that your index is going to be your denominator. You already have a denominator. Those are the ones you want to multiply to get your new denominator. The last set of instructions says simplify the statement and then determine if it is rational or irrational. Number 50. If I have the same index, I can multiply these two radicals together. The index is 2 because it's not written. So I get the square root of 21. Factoring 21 down to 3 and 7, those are my prime numbers. I don't have two factors of anything, so I can't take anything out of the radical. This is the simplified radical form. If you have a radical in your answer after you simplified, then that means you can't get a rational number from this. So my answer is irrational. You cannot add two radicals that don't have the same radicand and index. Your index must be the same, and here they are. But your radicand must also be the same. They are not. This cannot be simplified more, and there are radicals in my answer. This is the simplified version. My answer is irrational because I cannot simplify more than that. Number 52. The square root of 49 is 7. 4 plus 7 gives me 11. There's no radical in my answer. This is a rational number. "47 is a prime number, so I can't take any factors out of my radical. This cannot be reduced. This is an irrational number. There's a radical left in my answer." Number 54. I can add radicals if they are like terms. These are like terms if I have the same radical in each of my terms. The square root of 5 and the square root of 5 are in each term. That means I can add them. The square root of 5 will also be in your answer because it's like terms. Add the 2 and the 3 to get 5, and your answer is 5, radical 5. That cannot be reduced more because 5 is prime. There are no factors I can pull out of my radical. This answer is irrational. Number 55. Again, I need like terms. 4 and 6 are like terms. So I'm doing 4 minus 6. 5 square root 3 and negative 2 square root 3 are like terms. So I'm doing 5 root 3 minus a negative 2 root 3. If you want to distribute this negative first, it's a good idea so that you don't mix up subtracting a negative. Rewritten, after I distribute my negative, I subtract 6 and I add 2 root 3. Combining like terms, 4 minus 6 gives me negative 2. 5 root 3 plus 2 root 3 is a positive 7 root 3. So my answer is negative 2, 7 root 3. I cannot reduce the radical because the 3 is prime and nothing can be pulled out. This answer is irrational.